All right, so welcome back. This is video 2 from section 2.2 Gauss-Jordan. And so we're solving systems of equations using a technique called the Gauss-Jordan technique. Now we took a look at an example before and we'll just build on that. You'll notice that we have a much bigger system here. The example we did before was a 2 by 2. I'm sorry, a 2 by 2 system, 2 variables, 2 unknowns, which resulted in a matrix that was a 2 by 3. All right, so let's go ahead and just dive right into this one. First thing I have to do is I have to encode my system as an augmented matrix. So you'll see that we have 3 equations, 1, 2, 3. There are 3 variables as well as the constant. So it looks like we're going to have a 3 by 4 matrix. My first row will be 3, -5, -2, -9. My second row is -4, +3, 1, 11. And my third row will be the 8, the -5, the 4, and the 6. Now technically, there's a line right here to show that this is an augmented matrix, where these ones over here on the left represent our coefficients, and those are the constants that these are equal to. You don't need to draw it to do the math. It's just, it can be there. Okay? All right, so let's just jump right in. To start working this thing into the Gauss-Jordan reduced row echelon form, I need to make that entry into a 1, and I need to make those 2 entries into zeros. We make entries into 1s by multiplying or dividing. In this case, we'll divide by 3 to make that a 1. We make the -4 and the +8, the 2 pink highlighted ones, we'll make those into zeros by adding and subtracting rows. So the first thing I'm going to do is I am going to take row 1 and divide it by 3. So I am going to take row 1 and replace it with 1/3 row 1. Remember, dividing by 3 is just multiplying by 1/3. When I do that, I get a 1 here because 3 divided by 3 is 1. I get a -5/3. I get a -2/3, and I get a -3 over there on the right-hand side because -9 divided by 3 is -3. I'm leaving the second row alone, so I'm just going to copy it down. It's just going to stay -4, 3, 1, 11. I'll leave the third row alone. That's 8, -5, 4, 6. Okay? So I've got the 1 where I want it. I got this to be a 1. I'm happy there. Now I need to make this into a 0 and this into a 0. So that'll be my next iteration of this matrix. All right? So then I'm going to move to the next iteration. Now, since the first row already is the 1, I'll just leave it alone and copy it down. All right? Now to make that second row, make that -4 in that second row into a 0, I am going to take row 2 and I'm going to replace it with row 2 plus 4 times row 1. 4 times row 1 will give me a 4 in that first position, so the -4 plus the +4 will give me a 0 right here. So I know that's going to be a 0. I made it happen. Now the rest of the entries in that row, I'm going to have to do some scratch work over here to the side. So I'm just going to do some scratch work over here. So over here, this will be my scratch work. Okay. This second entry right here, the second entry that's going to go right here is going to be the old row 2 entry. That's the 3 from right here, plus 4 times the row 1 entry, so plus 4 times that -5/3. So that's going to be 3 minus 20/3. That's going to be 9/3 minus, 20/3. So that's going to be -11/3. So this will be -11/3. And it's kind of hard to read on that pink, so I'll erase the pink. Okay. Moving to the right, I need to find this one. Right. Again, it's going to be the old row 2 plus 4 times the row 1. The old row 2 in that third position was a 1, plus 4 times row 1, so 4 times -2/3, So that's going to give me 3/3 minus 12/3. Is that right? No, I'm sorry. Minus 8/3. 4 times 2 is 8 today. 3/3 minus 8/3 would be negative 5/3. And so I'm going to get a negative 5/3 there. So that one's done. Now I need to find this entry over here, that constant. So again, scratch work, it's going to be the old row 2, which was 11, plus 4 times row 1, which is negative 3. So it's going to be 11 minus 12, so negative 1. Okay, all right. So I'm done with row 2. Now I need to move on to row 3. Okay, so what is the math that I'm going to have to do in row 3? Well, I've got to make that 8 into a 0, so it looks like I'm going to take row 3 and this time subtract off 8 times row 1. I added before because my second row was already negative. Now I'm subtracting so I can get 8 minus 8 to get me my 0. So that'll give my 0 here. Now the entries for the rest of the row I'm going to have to figure out. Okay? To find this entry right here, this third row, second column, I'm just going to do the math. I'm going to take the old row 3, which was our negative 5. I'm going to subtract off 8 times row 1, which is a negative 5/3. So that'll be negative 5 plus 40/3. So that's going to be negative 15/3 plus 40/3. So what, 43, 25/3. So I've got 25/3 happening there. Okay, so that gets me that second entry. Now I'll move over and try to find that third entry. Okay, the third entry. Okay, third entry. Third entry is going to be the old third entry. That's 4 minus 8 times row 1. So 8 times negative 2/3. So that's going to be 4 plus 16/3. So that's going to be 12/3 plus 16/3. So 28/3. So we get 28/3 there in that third position. So I got that one. Okay. Last one over there, I need to get that 6, right? I need to find out what happens to this 6 up here. So let's see. The formula says it's going to be 6, old row 3, minus 8 times row 1, negative 3. So that'll be 6 plus 24. So I think that's 30. And so I get a 30 here. Okay. So now that I've got the first column looking like how I want it to look, now I need to make that second column look like how I want it to look. Meaning I need to turn this position into a 1 and then turn these two positions into zeros. And I'm out of space over here in my scratch work, and this is lots of fractions, and I'm probably going to make a mistake. So I'm going to make the following argument, that there has to be a better way. There has to be a more efficient way to do this, that this can't be the best way to do this mathematics. So I'm going to go and see if I can find a better way to do this. So let's see if I can do that. And I think the answer is going to be right there with the calculator. Okay? So I'm going to show you how to do this Gauss-Jordan technique on your graphing calculator. Okay? Step 1 of doing Gauss-Jordan on your calculator is still exactly the same. Now I'm going to pause the video here and get this screen looking a little better. So hold on one second. Okay, I'm back. I got the screen a little better so I can see my pen colors now. Step 1 of Gauss-Jordan in the calculator is exactly the same as step 1 in by hand. You encode the matrix as an augmented, encode as an augmented matrix. Encode the system as an augmented matrix. Step 2 is where things change. Step 2 is put that into your graphing calculator. Okay? So I'm going to come over here and I'm going to turn my calculator on and I'm going to go to the matrix menu, which is on that left-hand side. So second function, matrix. Then I need to put that calculator in there, or that matrix into my graphing calculator. The graphing calculator refers to this as an edit function. So I'm going to go over to edit because I want to input a matrix. I'll press enter. It brings me to my edit screen. Now there's some gobbledygook in there because I've used this before. But the first thing we need to do is we need to resize that matrix to make it fit what I've got. Now my matrix is a 3 by 4 matrix because it has 3 rows and 4 columns. So the first thing I'll do is I'll change the size of that matrix to make it a 3 by 4. Just literally typing in the numbers 3 and 4, press enter, and now it allows me to enter the individual entries. Now I don't need to clear out what's in there. I can type right over top of it. So our entries will be 3, and then enter, and then -5, enter, -2, enter, -9, enter, -4, enter, 3, enter, 1, enter, 11, enter, 8, enter, -5, enter, 9, whoops, I typed a 9, that should be a 4, enter, and then a 6. Okay. Now putting things in the calculator is the weak point, so I'll check my work. That last column looks good, -9, 11, 6. The next column over, -2, 1, 4, that looks good. -5, 3, -5, and the last is 3, -4, 8. That looks good. So once I've got the matrix in, I'm going to quit out of there using the second quit. And now I'm going to ask the calculator to make this into, this matrix that is not in reduced row echelon form, to make it into reduced row echelon form. So I go back to the matrix menu, I go over to the math drop down, and I'm going to scroll until I find the command I want, which in this case is letter B, RREF, the reduced row echelon form. I'll punch that up, and now it's sitting there flashing at me because the calculator needs to know which matrix to do this to. And I believe I put it in A, but I'm going to go back to matrix, grab that number 1 there, letter A, and then press enter. Now I'm going to make some space over here. I'm going to erase some of this work that we didn't need to do so I have some space. Again, this eraser is a mess because you have to touch everything you want to erase, and if you miss something, it doesn't erase it. I think I got everything. Well, clearly I didn't. There we go. Okay, and now I'm going to take that matrix that I just had and I'm going to copy it down over here. So there's my reduced row echelon form. 1, 0, 0, -3, 0, 1, 0, -2, 0, 0, 1, +5. And so I've got my augmented matrix in reduced row echelon form. And now what I'm going to do is I'm going to peel off what each of those rows mean. Like for example, this first row, that 1 in that first position means 1x. The 0 in the second position means 0 y's, and 0 z's is equal to -3. Remember, that vertical line right there, that's our equal sign. Okay? Now, no one would ever write it like that, because what's the point of writing 0 y's and 0 z's? So really, what we're looking at there is just that x equals -3. Same logic, the second equation is y equals -2. That's that second row. And then the third row is z equals 5. Or our solution is x equals -3, y equals -2, and z equals -5. And I don't have to push a pencil around on a piece of paper and do all this crazy scratch work to find values and work through the matrix. Okay? It just, the calculator is doing the work for me. You can also do this on Desmos. There's a matrix calculator within Desmos that does everything you can do here. Right? If you want information about that, reach out and I can show it to you. Right? All right, let's try another one. Let's try this one. Right? And you notice I have way less space set aside for this because I'm doing it as a matrix. But there's something different about this system. Do you see this hole right here, and this hole right here, and that hole right there? Do you see how that tells us that in the first equation there is no z variable being represented? In the second equation there is no x. And in the third equation there is no y. When we encode this matrix, we're going to have to deal with that. Right? So when I encode this matrix, my first row is going to be a 2, a -2, a 0, and a -5. Right? That 0, this 0 right here, that's telling the matrix that the first equation does not contain a z variable, or that the coefficient of z is 0. Second row, 0 for the x's, 2, 1, 0. And third row, 2, 0, 1, -7. Okay? So these zeros right here, these three zeros right here, are the zeros that are representing those missing variables. This 0 right here, totally different. That's just saying the equation is equal to 0. Because remember, right here is that vertical line that says here's left of this coefficients, to the right of this are our constants. Right? All right, now I need to take this and put this into my calculator. So I'm going to come back over to the calculator. I'm going to go back to my matrix menu. I'm going to scroll over to edit, press enter. This is the same size as before. It's still a 3 by 4, so I'm good there. But I need to change my entries. I've got a 2, a -2, a 0, a -5. I've got a 0, a 2, a 1, a 0 in my second row, and my third row is a 2, and a 0, and a 1, and a -7. Again, I'm going to check my work. Last column, -5, 0, -7, that's good. Third column there is 0, 1, 1, that looks good. -2, 2, 0, that looks good. And 2, 0, 2, that looks good too. Okay. I'll quit out of there. Back to matrix, over to math, scroll till I find RREF. I actually scrolled up because it's closer to the bottom than it is to the top to get me there faster, but you can scroll down too. I'll grab matrix A and I press enter and I get that. Okay, I'll go ahead and copy that matrix down in reduced row echelon form. So that's going to give me 1, 0.50, 0, 1.50, 0, 0, 0, 1. Now I've already noticed something disturbing. Normally we're looking for 1s on the main diagonal, but that last row's got the 1 way over there. Something seems off. In fact, something seems really wrong with this whole thing. So I'm going to go ahead and unencode this like I did last time. My first row is going to read x plus, well, this 0 right here means 0 y's. So that must mean 0.5 z's equal 0. That's weird. Second row is going to be no x's but a y plus 0.5 z's equals 0. And my third row is a whole bunch of zeros and then a 1. So what does that mean? I know it's equal to 1, but if a 0 in the matrix on those left 3 columns means none of that variable, does that mean 0 equals 1? And that I'm not sure what that's supposed to tell me, but I know it isn't something good because 0 is never equal to 1. That's what we refer to in mathematics as a false statement, because it's just not true. Okay? And so if that last row looks like that, if it looks like 0 equals 1 and it's a false statement, that must tell me something about the original system. In fact, what it tells me is that this system has no solutions. This is that scenario where the lines don't intersect and there is no solution for the system. So what I'm seeing here is I'm seeing a Gauss-Jordan row-reduced echelon form no solution problem. So how does it tell me that again? It's that row right there. That row of no x's plus no y's plus no z's is somehow equal to 1. And if 0 is equal to 1, well, that's just not true. Not true means the system has no solutions. Right. So I'm going to end the video here because we're at 20 minutes. Make this a little bit bigger. And just to review, how did I know this one had a solution? Well, when I unencoded it, it gave me a solution. The first row read 1x is equal to -3. The second row read 1y is equal to -2. The third row read z is equal to 5. There's my solution. How did I know this one had no solutions? Well, it told me it had no solutions because when I unencoded that reduced row echelon form matrix, this is what it was telling me. And there's that last row, that 0 equals 1, that makes the whole thing garbage, says we have no solutions for the entire system. Okay? We'll continue doing this with a few more examples and move in some word problems in the later videos. But I'm going to say goodbye for now. See you back here for part 3.